Part A, using the method of GDC, n equals to 5, I equals to 12, PV equals to minus 10,000, and P upon Y equals to 1, C upon Y equals to 1, then we will be getting the future value as 17,623.42. For part 2, C upon Y change it to 2, so you will be getting future value as 17,908.48. For part 3, C upon Y should be equals to 4, so your future value should be equals to 18,061.11. And for part 4, C upon Y should be equals to 12, then the future value will be 18,166.91. For part B, I should be equals to 12, principal value is minus 10,000, and P upon Y equals to 1, C upon Y equals to 1, future value equals to 20,000. Then n value should become 6.11, so n equals to 7. For part 2, I equals to 12, principal value equals to minus 10,000, then P upon Y should be equals to 1, C upon Y should be equals to 12, the future value should be equals to 20,000, then n equals to 5.81, so n equals to 6. Question number 6. An initial amount of 10,000, an extra amount of 10,000 is added after each year as deposited into a savings account at an interest rate of 5%. Find the value of the investment at the end of the first year. So 10,000 and plus is added. The first 10,000 which is added, it gets 1.05 or 5% interest, and at the end of the first year again 10,000 been added. So it becomes 20,500 at the end of the second year. So the first 10,000 will be having a privilege of gaining 1.05 to the 2 years, whereas the 10,000 which is added after the first year will have been earning the interest only for 1 year, and the 10,000 which is added at the end of the third year will not have any interest at all. So this is going to be the answer, 31,525 at the end of the 10th year. So you can see that this forms a geometric progression. So in that case, what am I going to do? That 10,000 is my initial investment, then 1.05 is the common ratio, and 11 whole to the power of 11, you should take one extra, minus 1 divided by 1.05 minus 1, which is going to be 142,067.87. This is by the formula method. Now I will be using by the GDC. For part A, I will be using with GDC. So in that case, I take I equals to 5, principal value is minus 10,000, and PMT also equals to minus 10,000, then P upon Y equals to 1, C upon Y equals to 1. Then in that case, set n equals to 1, your final value will become 20,500, n equals to 2, your final value will become 31,525, n equals to 10, your final value will become 142,067.87. Now that is for part A. Now part B, find the least number of full years for the value of the investment to increase to 200,000. So final value should be equals to 200,000. N equals to will give you 13.2. So n equals to 14. Next. Then he is asking, explain why the formula of the investment at the end of the nth year is given by this formula. If the last payment is not included, we subtract 10,000. So what am I going to do? That is, for the first 10,000, it will runs for n years. The first 10,000 will run for n years, so I'll be getting it out 10,000. So my future value will be, or final value will be 10,000 times 1.05 whole to the power of n. The second 10,000 will runs for n minus 1 years, 1 year less. So future value or final value will be 10,000 times 1.05 whole to the power of n minus 1. The last but one 10,000 runs for how many years? 1 year. So the future value will be 10,000 times 1.05 whole to the power of 1. So the last payment 10,000 will be having only 10,000, so it will not have any, what is this, interest. So this may be the first one, this may be the second one, and this may be the nth one and n plus 1. So the total sum will be now, total sum will be 10,000 times 1 plus 1.05 plus 1.05 square plus and so on 1.05 whole to the power of n. So it will become 10,000 times 1.05 whole to the power of n plus 1 minus 1 by 1.05 minus 1. That is the reason the formula will be applicable. Question number 7. An amount of 10,000 is deposited into a savings account at an annual interest rate of 5%. An extra amount of 1,000 is deposited at the end of each year. Find the value of the investment. So, first part, the first 10,000 will earn for 1 year, whereas the second 10,000 will not earn any interest at all, so it will become 11,500. Part 2, at the end of the second year, the first 10,000 will earn for 2 years, the second 10,000 will earn for 1 year, whereas the last 10,000 will not have any interest at all, so it becomes 13,075. Now at the end of the third year, 10th year, so 10,000, and it was not 10,000 over here, so just it is being added 1,000. It's not 10,000, it is 1,000. So it is 10,000 will earn for 10 years, whereas we are depositing only 1,000 for the remaining, not 10,000, we are depositing only 1,000. So it should be 1,000 for the remaining 9 years. So it's going to be, just now we have derived the formula 1.05 whole to the power of 1 term extra, 10 divided by 1.05 minus 1. So which is going to be 28,866.84. So be careful, it was 1,000 deposited at the end of each year. Find the least amount of number of full years the investment will exceed more than 50,000. So for that, keep the, what is this, we'll be using the GDC in that case. So first of all, I'll do the same question part A with GDC method. Part A with GDC. In that case, I percent should be equals to 5, PV equals to minus 10,000, and PMT is minus 1,000 because I'm investing 1,000. Then P upon Y equals to 1, C upon Y equals to 1. Then set n equals to 1, you'll be getting final value as 11,500. N equals to 2, you'll be getting final value as 13,075. And n equals to 10, you'll be getting final value as 28,866.84. Now for part B, keep the final value as 50,000. Then you'll be getting n value as 17.36. So n equals to 18. Now I explain why this formula holds good. So the first 10,000 runs for how many years? It will run for n years. The first 10,000 will run for n years. So 10,000 times 1.05 whole to the power of n. Whereas first 1,000, after that he is depositing first 1,000, it will run for only n minus 1 years. So it is 1,000 times 1.05 whole to the power of n minus 1. The last but 1,000 runs for 1 year. Last but one will run for 1 year. So 1,000 times 1.05 whole to the power of 1. The last payment is 1,000. It will not run for any year, so it remains as 1,000 itself only. So when I calculate the sum will be 10,000 times 1.05 whole to the power of n plus remaining all 1000 times 1 plus 1.05 plus 1.05 square plus and so on plus 1.05 whole to the power of n minus 1. So this will become 10,000 times 1.05 n plus 1000 times 1.05 n power n minus 1 by 1.05 minus 1. That's going to be the formula. Now question number 8. An amount of 10,000 is deposited into a savings account at an annual interest rate of 5% compounded monthly. An extra amount of 1,000 is deposited at the end of each year. Find the value of the investment at the end of the first year and 10th year. So for this, keep I% equals to 5. Principal value is minus 10,000 and PMT is going to be minus 1,000. Then P upon Y equals to 1, C upon Y equals to 12 because it is monthly, compounded monthly. So set n equals to 1, then the final value should be equals to 11,511.62. Set n equals to 10, final value will be 29,116.41. Now part B, find the least number of full years. For that the investment should be 50,000. So use GDC and keep the final value as 50,000 plus 1,000 because you are depositing 1,000 also. So you should be getting n equals to 17.15. So n equals to 18. Question number 9. An amount of 10,000 is deposited into savings account at an annual interest rate of 5% compounded monthly. An extra amount of 100 is deposited at the end of each month. Find the value after 10th first year and 10th year. So again, I% should be equals to 5, PV equals to minus 10,000 and PMT is nothing but what? Minus 100. Then P upon Y is 12, C upon Y is also 12. Then set n equals to 12 and final value will become 11,739.50. N equals to 120, final value because 10 years, then 31,998.32. For part B, use the GDC, keep the final value as 50,000, then you'll be getting n equals to 187.04, which is 188 months. Question number 10. An amount of 10,000 is deposited into a savings account at an annual interest rate of 5% compounded yearly. Find the value of the interest after first year. So I% equals to 5, principal value is minus 10,000 and P upon Y is 1, C upon Y is also 1. So for part A, 10,000 times 5 upon 100, which is going to be 500 euros. Then part B, if the amount 500 is withdrawn at the end of the year, find the amount remaining after the 10 years. So you are supposed to be withdrawing. So PMT is plus 500. Then final value, keep it as 10,000 future value. So you'll be able to get it as future value is 10,000. Then part C, if an amount of 400 is withdrawn at the end of each year, find the amount remained after the 10 years. So your PMT should be equals to plus 400. Then your future value calculate, it will become 11,257.79. If an amount of 1,000 is withdrawn at the end of each year, find the amount remaining after the 10 years. So for part D, PMT should be equals to plus 1,000 because we are withdrawing. Then the future value will become 3,711.05. The last withdrawal L made after n years, find the value of N and L. Last withdrawal means the future value should become 0. In that case, N equals to 14.2. So means after 15 years. So N equals to 15. The future value will become again go back and do minus 789.2928 and L equals to the last withdrawal should be 210.72 because future value is minus 789.28 but you are withdrawing 1,000, so we cannot withdraw 1,000, so I am left over only with 1,000 minus 789.28, So I should be able to withdraw only 210.72. Question number 11. Anne gets a loan of 20,000 for 10 years at a nominal annual interest rate of 15% compounded annually. So N equals to 10, I percent equals to 15, principal value should be equals to 20,000. Then future value should keep it as 0, P upon Y equals to 1, C upon Y equals to 1. Now find the repayment made at the end of the each year. So for that, calculate PMT, you should be getting minus 3985.04. Then find the total amount paid. So he is paying 3985.04 for 10 years. So therefore it is 39,850.04.4. Then total interest paid. So it is 39,850 minus 20,000. So it is going to be 19,850.4 also. Question number 12. Bill gets a loan amount of 20,000 for 10 years at a nominal annual interest rate of 15% compounded monthly. So N equals to 10 times 12, which is 120. I percentage equals to 15. Principal value equals to 20,000. Final value keep it as 0. P upon Y equals to 12 because monthly. C upon Y also equals to 12. Find the repayment at the end of each year. So calculate PMT. Calculator will give you minus 322.67. Then total amount paid 322.67 times 120, which is 38,720.40. Find the total interest paid. 38,720.40 minus 20,000 equals to 18,720.40. Question number 13. Chris gets a loan of 20,000 for 10 years at a nominal interest rate of 15%, compounded quarterly. If at all it is compounded quarterly, N equals to 10 times 4, which is 40. I equals to 15. PV equals to 20,000. F future value or final value is 0. P upon Y should be equals to 4 and C upon Y also equals to 4. Then calculate the monthly repayment. So PMT quarterly payment. PMT should be equals to minus 973.19. And how much is the total amount paid? 973.19 times 40, which is 38,927.60. And total interest paid 38,927.60 minus 20,000, which is going to be 18,927.60. Question number 14. Demetrius get a loan of 20,000 for 10 years at a nominal annual interest rate of R% compounded monthly. Terms of loan required monthly repayments is 300 euros. Find the value of R. So N equals to 10 times 12, which is 120. PMT equals to how much is that monthly repayments? 300. And principal value is nothing but how much? 20,000. Then future value should be equals to 0. Because it is monthly, P upon Y is 12, C upon Y is 12. Then calculate I percent for the first part, you should be getting 13.12. Total amount paid 300 times 120, which is 36,000. What is the interest paid? 36,000 minus 20,000. So which is going to be 16,000. Question number 15. A sum of 500,000 is invested at a compound interest rate of 6.3% per annum. The value of the investment will exceed 10,000 after n full years. Calculate the value of n. So it is 5,000 times 1.063 whole to the power of n is greater than 10,000. You can use the GDC and get the value of point of intersection of n as, what is this? 11, or n as 11.345. So which is going to be 12 years. Use GDC. Question number 16. 1,000 is invested at the beginning of each year for 10 years. The rate of interest is fixed as 7.5%. per annum interest is compounded annually, how much the first 1000 is worth at the end of 10 years. So at the end of 10 years, it will be 1000 times 1.075 whole to the power of 10, which is 2061. The total value of the investment at the end of the 10 years. So it's going to be 1000 times 1.075 to the power of 1 plus 1.075 to the power of 2, so on 1.075 to the power of 10. So which is going to be, I can take it as 1000 times again 1.075 common, so it becomes 1 plus 1.075 plus and so on 1.075 whole to the power of 9. So it is 1000 times 1.075. This one is GP, so 1.075 to the power of 10 minus 1 divided by 1.075 minus 1. Simplify that, 15,208. So see that your first term should be always 1 so that you could be able to use this formula in a perfect way. So that is the reason I have taken 1.075 common. Question number 17. 1000 is invested at 15% per annum compounded monthly. Calculate the minimum number of months required for the value of investment that is exceeding 3000. So it is 15% per annum, so it is going to be 1.25% per month. The interest rate is 1.25% per month. Now it is 1000 deposited 1.25, so 1.0125 whole to the power of n is greater than 3000. So use the GDC to get the value of n as 89. Lastly, question number 18 and 18. Michelle invested 1500 francs at an annual interest rate of 5.25% compounded annually. Find the value of Michelle's investment at the end of 3 years. So it is 1500 times 1.0525 whole to the power of 3, which is 1748.87, which is 1749 to the nearest franc. So next part B. How many complete years will it take for the Michelle's initial investment to double the value? So 1500 should become 3000. So equals to 1500, 1.0525 whole to the power of t. Use the calculator, you should be getting t value as 13.546. So it is 14 years. Next part C. What should be the interest rate if the initial investment should be double in 10 years? So 3000 equals to 1500 times 1 plus r whole to the power of 10. So 2 equals to 1 plus r whole to the power of 10. So 10th root of 2 equals to 1 plus r. So r equals to 10th root of 2 minus 1, which is going to be 0.010718 or 7.18%. Question number 19. In this question, give all the answers to two decimal places. Brian decides to purchase a new car with a price of 14,000 but cannot afford the full amount. The car dealership offers two option plans to finance the loan. A 6-year loan at a nominal interest rate of 14% compounded quarterly, no initial deposit required, and the repayments are made each quarter. Find the repayment after every quarter. So for part A, n equals to 6 times 4, which is 24. I equals to 14. Principal value equals to 14,000. Then future value, final value should be 100. P upon y equals to 4. C upon y should be equals to 4. Then gives me the PMT value as minus 871.82. Then find the total amount paid. Total amount paid will be 24 times 871.82, which is 20,923.68. Then total interest paid 20,923.68 minus 14,000, so which is going to be 6,923.68. Now part B. A 6-year loan at a nominal interest rate of 8% is compounded monthly. The term Terms of loan require 10% deposit and monthly repayments of 250. Find the amount to be borrowed for this option. So before that, what is he asking over here? In this case, 14,000. 14,000 is the principal value. Then it is a 6-year loan. The terms of loan to loan require 10% deposit and a monthly repayments of 250. So 10% of 14,000, which is 1,400. So the remaining will be 14,000 minus 1,400, which is 12,600. This is going to be the principal value, and n should be equals to 6 times 12, which is 72. So principal value equals to 12,600. PMT should be equals to minus 250. Future value or final value should be equals to 0. P upon Y equals to 12. C upon Y should be equals to 12. Calculate I. I should be getting 12.56%. Then calculate the interest rate. Amount to be borrowed is 12,600 and the interest rate is 12.56%. State which option Brian should choose and justify your answer. So it is your choice to write it out in which way. If at all you are choosing the first option, we can write it as Brian should choose option A since no deposit is required. Since no deposit is required. Or you can write it as Brian should choose option B because option A is 6,923.69, which is greater than option B, which is 5,400. How I got 5,400? I got 72 times 250 minus 12,600. So which is only 5,400. In option B is paying only 5,400. In option A is paying 6,923. So either you can write it out any one, either option A, then your reasoning should be no deposit is required. If option B, then you have to compare which one is less interest paid. Then finally part D, Brian chooses option B. The ship invests the money Brian pays as soon as they receive it. If they invest in an account which is paying 0.4% per month and an inflation is 0.1% per month, calculate the real amount of the money of the car dealership has received by the end of the 6th year. So in this case, they are depositing at 0.4%, but the inflation is 0.1%, so totally will be 0.3%. So the initial deposit 1,400 will have 1.003 for 6 years. At the end of 6 years will become 1,736.98. Then the remaining, the 250 plus 250 times 1.003, the remaining payments, 250 times 1.003 whole square and so on, 250 times 1.003 only one time. So it should become 20,058.43. So the total value will become 20,058.43 plus 1,736.4898. So we should be becoming 21,795.41. That's going to be the answer. But if you want to do by GDC method, The same thing, what we can do it out is, this one was 21,795.41. If at all you want to do by GDC method, n equals to 72, then I equals to 0.3 times 12, which is 3.6. Then principal value is minus 1,400, and PMT you are paying it out minus 250. Then P upon Y should be equals to 12. C upon Y should be equals to 12. Then your final value will become 21,795.41. It's going to be the same. Or if you can do it out in another way, I% you keep it as 0.3, principal P upon Y is 1 and C upon Y is 1, then you will be final value will become same 21,795.41. Question number 20. Themis sold his car at the beginning of 2020 and received an amount of 7,000. Find the real value of Themis amount at the end of 2020 given that the inflation rate is 1.1%. So n equals to 1, interest rate is minus 1.1, PV equals to minus 7,000, then P upon Y equals to 1, C upon Y equals to 1. Then the final value will become 6,923. Then part 2, given that the inflation rate is 0.1%. So n equals to 12 and I equals to minus 0.1, PV equals to minus 7,000, P upon Y equals to 1, C upon Y equals to 1, then the final value will become 6,916.46. Part B, find the real value of Themis account at the end of 2024 given that the inflation rate is 1.1%. So n equals to 5, inflation is minus 1.1, PV is minus 7,000, P upon Y is 1, C upon Y is 1. So your final value will become 6,623.38. Now, given that the inflation rate is 0.1%, so n equals to 60, I equals to minus 0.1, principal value is minus 7,000, P upon Y is 1, C upon Y is 1, then the final value will become 6,592.15. Themis decides to invest the money at 12% per year, compounded monthly. Find the amount he will receive back at the end of 2024. So for part C, n equals to 5, I% equals to 12, PV equals to minus 7,000, P upon Y equals to 1, C upon Y equals to 12. Then the final value will become 12,716.88. Part D, find the real value of the money he will receive at the end of 2024 if the inflation is 0.1%. So now for part D, the real interest rate will become 1 minus 0.1, which is 0.9%. Because per month the interest rate was 1%. Because 12% per year means it is 1% per month. So basically the original interest rate was 12 upon 12 minus 0.1, which is 1 minus 0.1, which is 0.9%. So n equals to 5 times 12, 5 times 12, which is equals to 60, I equals to 0.9, PV equals to minus 7,000, P upon Y equals to 1, C upon Y equals to 1. Then the final value will become 11,983.71. Part E, Themis decided to invest his money 12% per year compounded monthly and withdraw 150 at the end of each month. Find the amount remaining in his account at the end of 2024. So I equals to 12, PV equals to minus 7,000, but PMT is he's withdrawing. So therefore it is 150 plus 150. P upon Y will be 12 and C upon Y also will be 12. N equals to 60. In that case, find the final value, which is 466.43. Then finally, part F, find the month he will receive the last amount remaining. So What do I require? I require the final value should be equals to 0. Then n equals to 63.17 means it is 64 month. 64 month means it will be April 2025. So on April 2025, he will be getting it out the last final installment. So when you do by n equals to 64 in the calculator, your final value, future value will be minus 123.69. But he is withdrawing 150 every time. So it is minus 123.69. So he will be able to withdraw only 26.31 euros on the last month. That will be the balance. So that completes this video. See you in the next video. Bye.